Okay, today we're going to start chapter 4. In chapter 4, we're pretty much going to do the same thing we did in chapter 3, same types of problems, but we're going to solve them using a different method. It's called the simplex method. And with the simplex method, instead of graphing, we're going to use matrices. And the advantage of matrices is you're not limited to two variables. Anytime you graph, when you have x's and y's, you can graph them, but when you go to z, well, you can't do it anymore. So we're going to develop this method using the simplex, and everything should work out okay. I'm kind of combining 4-1 and 4-2. I guess today mostly I'm going to do 4-1, but I'm going to show you how to set things up. And then with 4-2, we actually get into doing the problems a little bit more on maximization. There's two types. There's maximization and minimization. Same thing we had in chapter 3. And there's only 3 sections of this chapter, but they tend to be a little more difficult. If you've not seen this before, this might be a real challenge for you. But we'll see how it goes. Okay, let's talk about what they call slack variables. Okay, and we get another piece of paper here. Write that down, slack variables. In this problem, we're going to have 3 of them. Okay, so let's start out with 6x plus 3y is less than or equal to 96. Okay, so as we look at this, it says less than or equal to, which means it could be less than 96. So what would happen if I had the 6x plus 3y, and I actually wanted to make it equal to 96? Well, if it's not equal to 96, I have to add just a little bit more. In other words, I have to pick up the slack. So I'm going to make up a variable. I'm going to call it u. So 6x plus 3y plus u is equal to 96. The u is the slack variable. Okay, let's go to the second equation. The second equation says x plus y less than or equal to 18. So I got x plus y, and let's say I want to make that equal to 18. So I have to add a little bit more to get it up there. We've got to pick up the slack. How much are we going to add? Well, it may not be the same as what we add over here. It might be a different variable, so I'm going to create a new one. I'll call it v. So I got u over here, I got v. Okay, slack variable, slack variable. And then the third equation, I've got 2x plus 6y less than or equal to 72. So again, what if 2x plus 6y is less than 72? So there I've got to add a little bit more to make that equal to 72. So I used u here, I used v there, I'm going to use w here. And those are common variables that they use. You could use anything but u, v, and w. And if you had 4 inequalities, then you got to come up with another variable. We're not going to do any of those, so we're not going to worry about that. Okay, so if we take those equations and think of it this way. So now using this one, I've got 6x plus 3y. Just kind of hang with me a minute. Plus u. This will make sense what I'm doing here in a little bit. Now I'm going to go get the other one. This one was x plus y. and then there's a V. Well, you can think of it, this is like the X column, the Y column, here's the U column, there's going to be a V column, there's going to be a W column. So on the second one, I'm going to have plus V. And when you go to the third equation I have here, it's 2x plus 6y, and then W is way over here. Okay, so here's the way I want you to think of it. On this one, it was 6x plus 3y plus, think of that, 1u plus 0v plus 0w, and that was equal to 96. The second equation, x plus y plus, here I've got to put 0u plus 1v plus 0w equals 18. And on this one, it's 2x plus 6y plus, I don't have any u, so that's 0u plus 0v plus w, and that's equal to 72. Okay, now there's one more thing. Let's go back up here. We had a profit function. P is equal to 80x plus 70y. If I take and bring, because if you look at what I got, I'm trying to get the same form. I got my x's, my y's, my u's, my v's, my w's, and the rest of it. So the x's have to come first. So just think about, let's take the 80x and bring it over here. And when you bring it to the other side, that becomes negative 80x. Bring the 70y over, so it's minus 70y. And then the p is going to be over here someplace for right now. I'll just put plus p, and that is equal to 0. Okay, so now here's how the matrix gets set up. The top row is going to come from right here. So if you remember with matrices, you drop out the plus signs, the equal signs, and the variables. So I'm going to have 6, 3, 1, 0, 0, and on the other side is 96. On the second equation, it's going to be 1, 1, 0, 1, 0, 18. And then on the third equation, 2, 6, 0, 0, 1, 0. Now there's some things, oh, I forgot. And then we got the last one. For my profit, I'm going to have negative 80, negative 70, 0, 0, and then 0. And then if you look at this, we had an X, a Y, and then we had U, V, W. We need a P column. probably going to mess you up here, but for P, I had 0P here, 0 there, 0 there, 1, and 0. And that's my matrix. Now, when you're doing the problems, I do not expect for you to go through everything I did there. I was showing you kind of why the numbers are the way they are. So let's go back and say I haven't done all of this. Here's what you're going to do as you do the problems. And this will make a lot more sense. So we're going to start out, we know we got a 6, we know we got a 3, we know we got a 1, we know we got a 1, I got a 2, and a 6. Okay, that makes sense. And then somewhere over here, you know you're going to have a 96 and an 18 and a 72. I'm not going to put them there just yet. Okay, so these are the coefficients. Now we know the bottom row comes from this. So since that's 80 and that's 70, let's just think of this as negative 80 and negative 70. The negatives are always on the bottom. So even though I got plus 80 and plus 70, I'm going to put the negatives down here. Then you know you're going to have something here in the middle. Well, if you go back to what I had over here, take a look at this. This part right here, that kind of looks familiar. See where the ones are? They're on that diagonal and zeros every place else. That's that identity. So when you come over to this problem here, you know you have 4 rows. So that means you're going to have a 4 by 4 identity. So 1, 0, 0, 0. You got 4 there. The next row is going to be 0, 1, 0, 0. Third row is 0, 0, 1, 0. And the last one is going to be 0, 0, 0, 1. There's your identity. And then we're going to fill in the 96. We said it's over here someplace. Now we know where it's at. And this last one down here is always a 0. Some people say, well, I understand those numbers. Where'd that come from? Well, that comes back from the profit function when I looked at the other sheet. When I was doing profit right here, that's always going to be a 0. Okay, now I'm going to take you through the process, okay? That's just setting it up. And once you've done this a few times, that's the easy part. Okay, and there's no easy way of doing this. We're going to follow the rules similar to Gaussian elimination. We have to get a 1 here. Okay, I got it. I just got to recant my thoughts here. Okay. You don't really want a 1 there, but you're going to get a 1. And as you look at the bottom, we want to find the biggest negative. On the bottom row, we're finding the biggest negative. Negative 80 is the number. Now, if you're thinking on a number line, negative 80 is not really bigger than negative 70. It's actually less than. But I like to think of it this way. This is more negative than what that one is. That's why it's bigger. The way we're thinking of it, that makes it bigger. Okay, so that means this is what they call your pivot column. Pivot column. Now it becomes real interesting. We got to do some calculations, and we're going to calculate what is called a ratio. So you take the last number, which is 96, and you're going to divide it by whatever number's in the pivot column, and it's 6. 96 divided by 6 is 16. The next row is 18 divided by 1, which is 18. And then you got 72 divided by 2, and that's going to be 36. Now on the last row, it's always 0 here, so this will always be 0. We're never going to use the bottom number, so they don't even think about it. We'll just stop there. Okay, now we're going to look at these three numbers, 16, 18, and 36. On the bottom, we took the biggest negative. On the top, we're going to take the smallest positive, which is this number right here. Smallest positive. If that's the smallest positive, that means this row, which is the top row, is now my pivot row. I don't know if you can see that. We'll talk about enough. You'll pick up on that. Now, when you do it that way, you can see you had a pivot column and you had a pivot row, and they intersect right here where the 6 is. Okay? That means this number right here is going to be my new pivot. I want to make it into a 1. So we know to do that, we're going to take 1/6 of row 1. And unlike Gaussian you could change rows and things like that. Okay, it's a little more straightforward with the simplex method. All we're going to do is multiply by 1/6. We don't really have any choices. So 1/6 of 6 is 1. 1/6 of 3, that's 3 over 6, that's a half. 1/6 of 1 is 1/6. 1/6 of 0 is 0. Then I got 0. And I got 0. And I already knew that was 16. That's the same number I had up here, because I'm taking 1/6 of it. Row 2 stays the same. Row 3 stays the same. And row 3 stays the same. We did all that to get a 1. Like Gaussian, once I get the 1, the definition of pivoting means we're going to find zeros in the other ones. Okay, so I'll get rid of that, move this up a little bit. Okay, so here's my third matrix, and this gets a little bit long. Top row is going to stay the same. It helps to be neat, because you'll look back at these a little bit later and you may not be able to read the numbers. Okay, to get a 0 here, I'm going to take -1 times row 1, add it to row 2. So -1 and 1 is 0, and I'm going to streamline this a little bit, but that's going to be -1/2, and a +1 is 1/2. -1/6 and 0 is -1/6. And then we're going to have 0 and 1 is 1, 0 and 0 is 0, 0 and 0 is 0, and -16 plus 18 is 2. Now we go to row 3. To get a 0 here, we have to multiply by -2 and add. So it's -2 times row 1 plus row 3. -2 times 1 is -2, plus +2 is 0. -2 times 1/2 is 1, -1. -1 plus 6 is 5. -2 times 1/6 is -1/3. -1/3 plus 0 is -1/3. Then you can have 0 and 0 is 0. 0 and 0 is 0. 0 and 1 is 1. And negative 2 times 16 is negative 32. Negative 32 plus 72 is 40. And then the bottom row we're going to multiply by 80 times row 1 plus row 4. 80 times 1 is 80 plus negative 80 is 0. 80 times a half is 40. 40 plus negative 70 is negative 30. 80 times 1 6, that's 80 over 6 or 40 over 3, and I'm just going to leave it like that. That's a little awkward, but that's okay. 80 times 0 is 0 plus 0 is 0. 80 times 0 is 0 plus 0 is 0. 80 times 0 is 0 plus 1 is 1. And 80 times 16. 80 times 16. 128. Plus 0 is 128. Okay, so let's look and see what's happened. I started out, once I got the matrix, I told you that was just the beginning. We got a 1 here by taking 1 6. Once we got a 1, we got zeros here. But look on the bottom row. Up here, we started with how many negatives on the bottom row? 2 of them, 1 here, 1 here. Now we get down here, we've only got 1. So we eliminated one of the negatives. So that was a cycle, called a cycle if you want to. In math, it's called an iteration. Here's a word for you. I'm probably going to misspell it. Iteration. I need to check that spelling. An iteration, if you hear that, just think of it as a cycle. That's what you need to know about it. Okay, so we got the end of that first cycle, that first iteration, and you ask yourself, are you done? Well, I don't know. How do you know when you're done? Well, when you can look at the bottom row and there's no negatives. Are there any negatives in the bottom row? Yes, there's one here. That means we are not done. If all the negatives had disappeared, then I'd be done. Okay, so we start the process over. So biggest negative tells us that this is our pivot column. You need to do something. If you just circle like I did, that's fine. Starting out, you might want to write that in there as a note to yourself. Okay, and then we come over here. We're going to take 16. We're going to divide it by whatever number's in the column, so that's 1/2. 16 divided by 1/2 is 32. Then you got 2 divided by 1/2. 2 here divided by 1/2 here. That's equal to 4. And then you got 40 divided by 5, and that's 8. Which one do we want? We had 32, 4, and 8. What do we do on the side? If you go up here, we want the smallest positive. The smallest positive is 4. So I'm going to circle that row. That's my pivot row. So you got a pivot column, a pivot row. And now, where they intersect, that's going to become my pivot. So the next step is we got to get a 1 in the second row. So the top row is going to stay the same. I'm just copying the same numbers over. I'm really trying to be neat, because if you don't, it comes back and really hurts you later on because you can't read anything. What number was that? Okay, to get a 1 here, I'm going to take 2 times row 2. 2 times 0 is 0. 2 times 1/2 is 1. That's my pivot, so I'm going to circle it. Very important that you circle your pivots. When you look back over later and try to follow your work, if you don't circle the pivots, you can't do that. And the same thing's true if I'm looking at your work. That's the first thing I look for. Okay, 2 times negative 1/6, that's 2 over 6 is 1/3. That's negative 1/3. 2 times 1 is 2. 2 times 0 is 0. 2 times 0 is 0. 2 times 2 is 4. Row 3 stays the same. And row 3 stays the same. Okay, we got one more matrix. We got the 1, now you got to get 0. So to get a 0 up here, I'm going to take negative 1/2 times row 2 and add it to row 1. So negative 1/2 times 0 is 0, plus 1 is 1. Negative 1/2 times 1 is negative 1/2, plus 0 is 0. Negative 1/2 times negative 1/3 is 1/6. 1/6 plus 1/6 is 2/6, that's 1/3. I'm streamlining that. If you can't see where I got the 1/3, don't worry about that right now. Just follow along with what I'm doing with the rest of it. Negative 1/2 times 2 is negative 1, plus 0 is negative 1. Negative 1/2 times 0 is 0, plus 0 is 0. Negative 1/2 times 0 is 0, plus 0 is 0. And negative 1/2 times 4 is negative 2. Negative 2 plus 16 is 14. Top row's done. Second row, all I'm doing is copying because it stays the same. Row 3, to get a 0 here, I have to multiply by negative 5 times row 2, that's where the pivot is, add it to row 3. So negative 5 times 0 is 0, plus 0 is 0. Negative 5 times 1 is negative 5, plus positive 5 is 0. Negative 5 times negative 1/3, that becomes 5/3. 5/3 plus negative 1/3 is going to be 4/3. Negative 5 times 2 is negative 10, plus 0 is negative 10. Negative 5 times 0 is 0, plus 0 is 0. Negative 5 times 0 is 0, plus 1 is 1. Negative 5 times 4 is negative 20, plus 40 is 20. Okay, then the last row, I want to get a 0 here, so I'm going to multiply 30 times row 2 plus row 4. Okay, so 30 times 0 is 0, plus 0 is still 0. 30 times 1 is 30, plus negative 30 is 0. Negative 30 times negative 1/3, that's going to be negative 10 plus this. Think of that negative 10 as being, well, if you go back, that's negative 30 over 3 plus 40 over 3 is 10 over 3. 30 times 2 is 60. 60 plus 0 is 60. 30 times 0 is 0, plus 0 is 0. 30 times 0 is 0, plus 1 is 1. And 30 times 4 is 120, plus 128 here. So 120, that's 248. Now we're ready to find the answer. We've done all the work. We just have to look at it and come up with an answer. Extend my paper down here a little bit. Okay, so if you remember on this problem, we were trying to maximize the profit. And that's going to be that number right there. So it's 248. Think of that as $248. Okay. Now we got to figure out what's X and what's Y. At X equals Y equals. This is a little tricky. But if you go back up here, remember how I talked about this is the X column and that's the Y column? Look at the X column. There should be, well, first of all, this should be a unit column. A unit column means you have a 1 and the rest of them zeros. Okay, so where is the 1? The 1's right here. So that means the X value, if I follow the 1 and go straight across, X is going to be 14. In the Y column, the 1 is here. It's a unit column. I go across here, I get 4. You can think of that as being 14, 4. And if you remember on this problem, I didn't say this, but it's the same problem that we used as an example in chapter 3. And I think we were talking about sofas and chairs or something like that. So we would maximize it if this was, 14... I was trying to check real quick, make sure I said it right, but, so my maximum profit would be $248, and I would achieve that if I had 14 sofas and 4 chairs or vice versa, whatever they were. Okay, so let's go back and talk about, just quick review this whole problem. So we started out with this. This was the same problem from chapter 3. So the first thing you got to do is write that into matrix form. So that was my first step. Once I get here, I've got to identify where the pivot's going to be, and I do that by finding the biggest negative, which gives me the column, and the smallest positive, which gives me the row. So 6 is the number I want to work on. I want to get a 1 there. Just like Gaussian, to get a 1, you multiply by the reciprocal. So we take 1/6 of row 1, that gave me these new numbers. Rows 2, 3, and 4 stayed the same.